All right, we are moving on to the 9.5 section of the notes, which is all about symmetry and rotations. And so this is going to be super quick, and then you'll have, of course, whatever time left to work on homework, guys. So get ahead as much as you can. So the first thing we're going to talk about is line symmetry, which is also sometimes called reflection symmetry. So it's when a figure can be mapped or like reflected onto itself and make the same image. Like butterfly wings, when you fold a butterfly in half, the wings match up perfectly to the other side. So it's reflecting onto itself across a line that is said to have a line of symmetry. So if I look here, my first example, this line here, if I folded this shape in half, this piece of paper in half, those two sides, side one and side two, would match up perfectly with each other. So this is my line of symmetry. Okay. So if I look at each of the items, figures, I want to decide, does it have a line of symmetry? How many does it have? How does this work? So if I look at my starfish here, the lines are already created for me. But if you look at that, each time you look at that line, if you fold the two pieces over that line, each one of those works. So this has multiple lines of symmetry. Oh, how about this other thing? This thing looks kind of like it's trying to be like a 2D spaceship. So let's see, if I cut it this way, does that work? No. This way? No. Let's see, what about if I cut it this way? Does that look like that perfectly cuts it? I think it does. So it has one line of symmetry. And then I want to look down here at my crab. So same idea. Does this work? No. Does this work? No. So his line of symmetry is going to go right down in between his eyes, and he is going to fold up in half perfectly. You can find lines of symmetry if you want to like draw things out or cut them out and fold them. That's, that works for some people. One really important thing to remember, so make sure you write this down, is that regular polygons, we've talked about regular polygons before. Reminder, regular polygons are shapes with all congruent sides and angles. So all the sides are congruent and all the angles are congruent. Those are what regular polygons are. We'll see a lot more of those coming up in chapters to come. So when you have a regular polygon, the number of sides is equal to the number of lines of symmetry. So if I have an equilateral triangle, which is a regular polygon, all three sides are congruent and all three angles are congruent. It has three sides, so it has three lines of symmetry. Let's look at some of these figures. I have a heart. Last name. Yeah, I know, guys. Can that work? No. So let's see, right down the middle this way, it has, that was not very straight, one line of symmetry. And then I have a pentagon here. I'm going to give you a little hint and tell you that it's a regular pentagon. All the sides are congruent. And if all the sides are congruent, then it's going to have 5 lines of symmetry. How does that work? How does this thing have 5 lines of symmetry? I don't see it. Let's see. You go from each corner or each angle and go to the opposite side. So there's a 1. Next angle to the opposite side, 2. Next angle to the opposite side, 3. Next angle, 4. And across, 5. So you have 5 lines. You're not going to go around and count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, because that line is going throughout the entire shape. So it's one long line. And then we're going to look at our little cross thing here, little symbol, and I can go down the center as such, I can also go down the middle this way. Now, what if I fold it diagonally? If you turn your paper a little bit, doesn't it look like an X? And don't you think you can fold that X in half? You are correct. You can. 3 and 4. So this has 4 lines of symmetry. So you're going to have to, practice sketching some stuff out, drawing on them, maybe using an expo marker or even like a straight piece of paper, like a thin straight piece of paper to mark the lines on your screen if you need to. Whatever works for you guys.